print hello world. You know? Let's say print hello world, and then we're going to say rec, right? So this is an example of a recursive function. I'm just going to remove this now, and then so what's going to happen is this function, right? And if I invoke it here, what's going to happen when I call it, essentially, it should just print hello world, right? Remember when we're talking about recursion, and I said there always has to be a base case, a terminating condition. But if you look here, I haven't put anything first. So I just want to show it just for illustrative purposes. Fortunately, Python has a safety check where if you enter a loop, a recursive loop, and it sees that there's no terminating condition, I think after 500 iterations, it will stop. All right, cool. Let us terminal. Let us clear our previous workings, and there's no such thing as layer. It says clear. Cool. And then we're gonna run, and there we go. It's just going, and then boom, we had a recursion error. Right. We'll get to these type of errors and how we handle them in Python. Okay. I guess it's not 500, 900, more than 900, right? Times. So I think it's 1,000. There we go. Okay. So now let us create a terminating condition, right? I'm going to put in a number, n, which we could think of as a count, right? And then what we're going to say here is if the n, the count, is equals to 500, we just want to test 500, right? Return. So we're going to exit the function. That's our terminating condition, right? Exit the function. Just remember the return immediately stops the execution of the function, right? And then, so we have to do something. We have to change n, right? So we're going to do n. We have to like increment it, right? So that n just doesn't stay whatever number that we put it. We have to increment it. All right. And so I am going to then give it a value of 0, and that should increment. And then if I run this, and there you go. And it ran for 500 times. Okay. And if you even wanted to see that, we could even say hello world. And then we could put n here and then see how many times. So this would be telling us how many times it's run. We can just do that. 500, 02499 is 500. Okay. So I want to show you how this function is actually working. And I'm just going to remove, it's called a tracing tree. Let's draw a tracing tree for this function. Okay, I'm going to remove that and just put n. And then we're going to change this a bit. It's going to say n is 0. So now we're going to decrement the count. So whatever number I put in, I'm going to decrement it. So we're going to start at just 3. Okay. And we can see if we run it, it just prints n 3 times. No, 3, 2, 1. Okay. And remember, when it got to 0, it exits the function. So I'm just going to show you a tracing tree on how this works. Okay. So we are on a Jamboard, right? And this Jamboard is essentially just going to show you, I'm just going to draw the tracing tree, okay? There might be a bit of a lag. I'm drawing from another device, okay? But let's get to it. So we have the function rec, right? And we call rec 3 times, right? And then we're going to, right? So remember, it says if n is equals to 0, return, but n is 3. So we're just going to, we're going to say print 3. Then we're still in our recursive call, and it's now going to be rec 2 minus 3 minus 1, which is 2. So it's going to be rec 2, right? And then when we get to rec 2, what is this? N now? N is 2, so we print 2. Then we have another recursion call. It's going to be rec 1, right? Then we're going to print P1, and then we get to what's 1 minus 1. That is now 0, so we exit our function. So then what happens is, now that we've gotten to the end here, we now go back to rec minus 1. We see, was there anything below rec -1? No. Okay, cool. So we continue. Was there anything that we had to execute after rec2? No. Then we end at, and then that's the end of the function tracing tree. Okay, guys. So, all right, guys, just made a minor adjustments just to illustrate what's actually happening. So let's start from the top. Rec3, right? We print 3 there. We print 3, and then from there we go to rec2, where we then print 2. Okay. Then from there we now have another recursive call, rec1, right? And then we print 1. Then we have rec1 - 1, right? We're still going to call this, but then we now see that our terminating condition is our terminating condition. 1 - 1 is 0, so therefore n is 0, then it'll exit. And then from rec - 1, we have to go back and check if there was anything that we needed to execute below. Nothing. Then we continue, and we continue to the top, and then we end the function. Okay. We'll do another example just now. See you there. Okay, so now we're gonna do another one. We're gonna write another function, another example, recursive example, and I'm just going to copy and paste that, and I'm just going to change it to 2. We're still going to have the same terminating condition. However, this time, what we're going to have something that executes after the recursive call. Right? I just want to show you what happens there, and that's going to be 2, right? And then I'm going to invoke it again. Then I'll now show you a tracing tree. All right, so we call you, and there we go, 1, 2, 3. All right, different from the other one. So I'll just show you how that works. See you there now. So we're gonna have rec2, right? And it is going to be, that's our first, we're starting at rec2. Then we have a, now you see, we check is n equals to 0? No, it's not. So we continue. So okay, we have another recursive call where we decrement n. So that's now gonna be rec2, and it's going to be 2. Okay, then we, all right, called it again. So now we're going to decrement. So now we get here, we're going to decrement it again. So that's going to be now rec. That should be a small n r, not a capital. Rec2 1. Then we go down again. Then from there we have rec 2 1 - 1, and this is the terminating condition, so we end there. And then so that ends there. So now we have to go back here. What do we have? So there was something below here, but n is 0, so but we don't get to that point because we exit. But then we get to here, and then there's rec 2 1, but then we have a print n, and then we're gonna get 1. All right, that's what the first thing we should print. Then we're going to get here, we're going to go back, and that should be p1, sorry. So small k. Then we're going to go to rec2, and okay, well, we still have that print below. Then it's going to be p2. And then we're going to go, we're going to get p3, right? So that's how it works. So we're going to get 1 2 3. All right. If I'm not mistaken, that's what we got in our Python recursion, you see? So that's the order. So it's going up like that. That's the order of the execution. Okay. And I'll show you another example of a tracing tree. We have the third version. We have the same base condition. We take the same parameter n. However, we have something before our recursive call and after our recursive call. So I just want to show you how that will look like. Okay, guys. Welcome back. So let's start again. So it's going to be rec. It's going to be rec 3 of 3. All right. And then we're going to print ul. Right. So we're going to have ul. And then we're going to have a recursive call of rec 3 of 2. All right. Remember 3 minus 1 is 2. Then remember, so enter the function again. It's now going to print ul. Then we're going to have rec 3 of 1. We're also going to have another ul. Right. And then we are going to have our rec 3 of 1 minus 1, and that is terminating because that becomes 0. And then remember, like I said before, we're going to move up here, and we're going to have another ul. Then we're going to go back up, right? We're going to have another ul because there's something below that, and we're going to have another one. Go back up, and it's going to be another UL. Right, so it's going to be in the order of, so this is going to be the first print, 1, 2, 3, 4, 5, and 6. All right, guys. So this is just some tracing trees for recursion. And let me draw some arrows here to make sure that we are clear on the matter. Okay. See you guys when we get to our factorials and the Fibonacci sequence using recursion. Cheers.